Alright, let's get with chapter 7.5, which is learning how to graph a hyperbola. Hyperbolas are very similar to ellipses. If you notice the equations here, the two forms of the hyperbola go as follows. X minus h quantity squared over a squared minus y minus k squared over b squared equals 1. Same thing here, except the y seems to be on the left side and the x seems to be on the right side. Again, very similar to the ellipse, except that the hyperbola is being subtracted. The characteristics of the hyperbola are very similar. The center is still negative h negative k, even in the right side example here where the x is on the right side. It's still negative h negative k. The hyperbola always continues to equal 1, just like the ellipse. A is still the major axis, and B is still the minor axis, and C is still the focal distance. The only thing that really changes is that the focal distance, remember that CAB formula backwards that I showed you in the last lesson? Instead of c squared equals a squared minus b squared, the reason why we call it CAB formula backwards or CAB formula opposite is because in this case, c squared is going to be found by a squared plus b squared. And so if I was to draw a rough sketch of what each of these hyperbolas look like, the left hyperbola where the major axis is underneath x, it's going to be a side-to-side hyperbola. In the right side scenario where the a squared, the major axis, is underneath the y term, it's going to be an up and down hyperbola. The only thing that's going to matter, or the only thing that's going to be different in terms of the hyperbola versus the ellipse, is that you're going to have to find the slopes of what we call the asymptotes of the hyperbola, and we'll get to that as soon as we get there. So let's go ahead and just do a couple of examples. So one, if I gave you y squared over 36 minus x squared over 4. First thing we got to do is we got to identify what type of hyperbola is this. Well, since y is coming up first, that means that it's going to be an up and down hyperbola. Since y is coming first, oops, and I forgot that equals 1. So let's figure out everything that we know about this problem. It's just like the ellipse. We're going to identify the center, which is 0, 0. A, in this case, is going to be 6. B, in this case, is going to be 2. And C, well, that's going to be found using c squared equals a squared plus b squared, which is 40. We're going to take the square root of that. That is 2 rad 10. The square root of 40 is approximately, it leans more towards 36 than it does 49, which means that we are about 6.3 or 4. Alright, so I think we have enough information to graph this hyperbola. Now again, I know I haven't shown you how to graph a hyperbola yet, but you will get it. It's just like graphing an ellipse. Okay, we're going to start at the center, 0, 0. My major axis is 6. Now my major axis is underneath y, which means I'm going to propel up and down 6 because, again, major axis is underneath y. Y is the vertical motion. So I'm going to move up 1, 2, 3, 4, 5, 6. Down 1, 2, 3, 4, 5, 6. And now I'm going to move to the left and right 2 times. From here, instead of drawing an ellipse like before, I will not draw the ellipse. I'm actually going to draw a box. I'm going to draw a box instead, and I kind of missed that point there. Sorry about that. I'm going to draw a box instead. Now, through the box, I'm going to go ahead and draw dashed lines. And the dashed lines are supposed to hit the corners of the box. Now, I don't want you to draw points right there, but they're supposed to hit the corners of the box. And I understand that's not very straight, but that's okay. Now, these dashed lines are what we call asymptotes. And asymptotes are dashed lines that are represented on a graph that basically tell us where the graph cannot cross. So whenever we have an asymptote on a graph, which we will study later on in the year, you will find that the graph cannot cross that little zone of the graph. Now, since this is an up and down facing parabola, or hyperbola rather, I'm going to draw one hyperbola here, and then one hyperbola here. Okay, and I realize that's too much yellow. Let me distinguish the graph here. Okay? So there's a blue hyperbola up top, and then the blue hyperbola on bottom. Now, the focal distance. The focal distance is about 6.4, so that's going to be 6.4 from the center. So up, 1, 2, 3, 4, 5, 6, and a little bit more. I realize I'm not that accurate, but that's okay. And the same thing here. Just like the ellipse, the foci always lie on the major axis. And since the major axis was 6, and the major axis was underneath y, we move up and down to find our focal coordinates. Now, finding the asymptotes is the slope of the asymptotes is going to be a little bit different. Let me scroll over here real quick. Run out of space. Okay, to find the slopes of the asymptotes, I'm going to go ahead and scroll up a little bit. Or no, I'm not. To find the slopes of the asymptotes, I'm going to go ahead and change colors real quick. And I want us to think, what is slope? Well, slope is rise over run, or sometimes they say change in y over change in x. And so when we think about the slope of the asymptotes, I want you guys to think of it in terms of x and y. When we look at this hyperbola, we have the y term on the left and the x term on the right. When we look for the asymptotes, I want you to think of the denominators of y and x. The denominator of y is going to be the a squared term, which in this case a is 6. So I want you to write that down, 6. And that's going to be over the x denominator, which in this case b squared is 4, but b is 2. And it's going to be plus or minus because we have a negative slope and then we have a positive slope. So the slope of the asymptote is really plus or minus 3 over 1. Because, again, the change in the denominator over the change in the denominator of x. Change in the denominator of y over change in the denominator of x. Okay? So this downward facing line is the negative 3 over 1. The upward facing line is the positive 3 over 1. And you don't need to write these down. I'm just trying to show you what that looks like. And then finally, we need to find the focal coordinates. The focal coordinates are going to be, looks like 0, 0 plus or minus 2 rad 10. Okay, I realize that was a little bit much to take in, but let's go ahead and do another one to see for full comprehension. And I think in terms of the slope of the asymptote, I think just doing a couple thousand of them will definitely help. Let's do another example. X squared over 25 minus y squared over 16 equals 1. Okay, so let's go ahead and just label everything that we know. First of all, because the major axis, which is the first number in a hyperbola, is underneath the x, we know that it's going to be a side-to-side hyperbola. And the center, just like the last one, because there's nothing happening, it's 0, 0. A is going to be 5, B is going to be 4, C is going to be C squared equals A squared plus B squared, so 25 plus 16, that is 41, but the square root of that. Okay, the square root of 41, I'm going to erase this work right here. The square root of 41 is about 6 point, see it's leaning a little bit more towards 36, so maybe 6.4. Alright, let's go ahead and graph this thing. Alright, 0, 0. Now my major axis is underneath the x. So this time I'm going to move side to side 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My minor axis is 4, so I'm going to move up 4 and down 4. And now again, instead of drawing the ellipse, I'm going to draw the box. Whoops. That's horrible. and then some dashed lines are going to go through the corners of the box. And because I am dealing with a side-to-side hyperbola, I'm going to draw my hyperbolas this way. My focal coordinates, or the focal locations, are going to be out 6.4 in each direction, so 1, 2, 3, 4, 5, 6, and a little bit more. Just about a little 6.5, and then 1, 2, 3, 4, 5, 6.5 here. So let's find the slope of the asymptotes. We know it's going to be plus or minus. Remember, it's change in y over change in x. So in this case, change in y, in this case 16, we need to take the square root of that, which is 4, over change in x. In this case, the term underneath x is going to be 25. So that is 5. So it's always the denominator of y over the denominator of x. All right, that's number 2. Let's do another one. Okay, so let's go and sketch this hyperbola out. We know it's going to be an up and down one. And I think the problem with this is that a lot of you might lend towards the 16 being the major axis because it's the bigger number. Remember, the major axis always comes first in the hyperbola. One of the ways I like to think about this is, imagine this is negative 16. If you want to think of it in terms of bigger and smaller number, 9 is bigger than negative 16, right? So just make sure you make that distinction. The center is going to be 2, 3, right? Opposite of h, opposite of k. A, B, and C. Well, A is the major axis. A is going to be 3. The minor axis is going to be 4. Now again, that can be a little off-putting at first, but the hyperbola is one of those strange conic sections where the minor axis can be longer than the major axis, so keep that in mind. C is going to be the sum of those two, so that's going to be 5. 9 plus 16 is 25, square root of that is 5. So let's go ahead and graph this out. My center is at 2, 3. 2, 3 is here. I'm going to move out 3 spaces in each direction. 1, 2, 3. 1, 2, 3. And then up and down 4. 1, 2, 3, 4. And then 1, 2, 3, 4. Again, the hyperbola is one of those strange conic sections where the minor axis can actually be longer than the major axis. Draw your asymptotes through the corners of the box. And remember, this is an up and down hyperbola, so go ahead and draw the hyperbola. I'm going to switch colors for that. I'll switch to blue. And then my focal distance is 5, so from here I'm going to go down 1, 2, 3, 4, 1, 2, 3, 4, and 5. So I'm going to be just a little bit here, and then 1, 2, 3, 4, and 5. So let's find the equation for the asymptotes, or the slope of the asymptotes. So remember, it's change in y over change in x. So it's going to be plus or minus. The change in y is 9, but we're going to use the square root of that, so that's 3 over change in x, which is 16, 4. My focal coordinates are going to be 2, 3 plus or minus 5. All right, number 5. I'm going to do one example of completing the square with a hyperbola. It's kind of the same thing as the ellipse. So what I'm going to do is I'm going to rearrange all this stuff and move 96 over to the other side. So I'm going to say 4x squared minus 8x minus 25y squared equals 96. I'm going to factor out a 4, and I'm going to have x squared minus 2x minus 25y squared equals 96. Now I'm going to add the box. And I'm going to add the box on the other side, except the box, remember, it interacts with the 4, so it's going to get multiplied by 4. We know this already. This should be negative 1, and negative 1 here. I should have 4 parentheses x minus 1 squared minus 25 y squared equals, this is 1 times 4 is 4 plus 96 is 100. Divide everything by 100. I end up with, let me scroll down here, I end up with x minus 1 quantity squared over 25 minus y squared over 4 equals 1. This is the equation that I am dealing with now. I used completing the square to get there, so let's go ahead and do the whole thing. So center is going to be 1, 0. A is going to be 5. B is going to be 2. Remember, the major axis is underneath x, so let's go and draw a quick little sketch of this too. It's going to look like that. C is going to be, well, c squared equals a squared plus b squared, so that's rad 29, which is approximately, let's see, closer to 25, so it's a 5.3. Let's go and graph this. Center's at 1, 0. I'm going to move out to the left and right 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to move up and down 2. And I'm going to go ahead and draw the box. And I'm going to draw dashed lines through the corners of the box. Remember, it's a side-to-side hyperbola, so it's going to do this. I realize it's not exactly proportional, but that is a lack of drawing ability. My focal distance is 5.3, so that is 1, 2, 3, 4, 5, and then a little bit more. 1, 2, 3, 4, 5, and a little bit more. Let's find the slope of the asymptotes. Slope of the asymptotes, remember, change in y, so it's going to be, first of all, plus or minus. Change in y, which is 4, so in this case it's going to be 2, over change in x, over 25, which is 5. And then my focal coordinates are going to be 1 plus or minus rad 29, 0. Okay, that is it for the hyperbola. We'll see you next time.